Hello and welcome to the first of two videos for Module 3, Topic 1, Simple and Compound Interest. So be sure to watch both videos, and remember, with watching a video lesson, you're able to stop and replay any part of the video if you wish to do so. All right, let's begin with simple interest. So first, we need to talk about interest. And interest is the dollar charge that people pay or receive for the use of money. With simple interest, the interest is calculated on the original amount, which we will refer to as principal, over a specified time period. The charges are based only on the amount of the money originally borrowed or invested. Normally, it's based on a year as a stated annual rate of interest, which we often refer to as per annum. To calculate simple interest, we're going to use this formula. So the formula is I is equal to P times R times T, where I is the amount of interest paid or received, P is the original amount invested or borrowed, which is the principal, R is the rate of interest per year, and it's expressed as a decimal per annum. And then finally, T is the time period money has been borrowed or invested. It's expressed in years, but can also be expressed as a fraction of a year or month, depending on the interest rate. So we're going to be sure to take care at making sure that we read our questions carefully. So first, let's focus in on rate in decimal form. So what we just need to do is convert percentage into a decimal. And we want to make sure that we don't round our answer. So here, our first question shows 10%. We remember to convert percent into a decimal, we simply think about dividing by 100. So if I write it as 10 divided by 100, I get the decimal value of 0.1. The other thing you can think about is simply moving the decimal place, 2 spots to the left as well. All right, next percent is 2%. So following that same idea, either moving the decimal place 2 spots to the left or simply dividing by 100, you should get the decimal of 0.02. And then for 0.35%, please remember you can have decimals that are also percentages, but we still, to convert it to decimal, we still have to take that percentage and again divide it by 100. So again, you can think about moving the decimal place 2 spots to the left or divide it by 100, which gives us a decimal value of 0.0035. So be mindful that your rate, when you put it into your formula, needs to be in decimal form. All right, let's move on to time. So time in years. So sometimes we're given the time in years, which is very clear. We can just substitute that into the formula. But other times we might be given time in a different unit. So our first example here is very straightforward. 2 years, so T is equal to 2. Now our next question is 6 months. So we need to convert 6 months into years. And what we're going to do is essentially leave it as a fraction. Sometimes it turns into a nice decimal, but not always. So it's good practice to remember that 6 months is the same as 6 over 12 years. Or this is a nice decimal, which would be 0.5 years. But as I said, that's not always the case. Now, sometimes too, we might be given time in days. And again, we can convert that into years. We remember that there's 365 days in 1 year. So we can write this as the fraction of 256 over 365. And that would convert our 256 days into years. So let's do our first example. So it says solve the following simple interest problem. So let's read it and let's highlight some of the important bits of information that are found in this particular question. We have that a technician borrows $800 at 8.0% per annum for 2 years. He is charged simple interest on the loan. The question is, how much would the interest be? All right, so let's write down what we have. We have our I value, that's what we're solving. My apologies. We're solving for I. We have our P value, which is our principal, which is $800. We also have our rate. It was 8.0% per annum, which again, remember, we are going to ensure we use that percentage in decimal form when we go to substitute it into the formula. And then finally, we have our time, which is 2 years. So when we go back to our formula for simple interest, we have that interest is equal to PRT. Remember, it's P times R times T. So when we go to do our substitution, we have a principal of 800, a rate of 0.08, and time of 2 years. When I plug that into my calculator, I get $128 in interest. Be sure that when you are working with simple interest questions, as well as when we get to compound interest, that when we're working with money, always remember you need to include the dollar sign, and please remember to always round to 2 decimal places. Okay, so carrying on with another practice question. This question says, how long will it take a $300 investment to earn $60 interest at 8.0% per annum simple interest? And we're going to round this answer to 1 decimal place. All right, let's highlight what information we have. So we have this $300 investment. So that's our principal. We're given that it earns $60 interest. We have our rate, which is 8.0% per annum. And so what piece of information are we missing? Well, the question asks, how long will it take? So we're actually going to be solving for T for this question. So if it comes to interest, we have the given value of $60. For principal, we have the value given of $300. We have, again, the same rate as last time, 8.0%, which again, we always use in decimal form. And what we are solving for is T. That's what we don't know. Okay, so if we look at our original formula for interest, simple interest, we have that I is equal to P times R times T. Now, what we want to isolate for, what we want to solve for is this T. So we want to isolate that T first. So in order to do that, I can divide both sides by P times R. And again, we'll see it will cancel on that side. So what we have is I divided by P times R is equal to T. Now, for some of us, we don't like the T on the right-hand side. You can always just flip the whole thing if you prefer to work in this manner before you do your substitution. All right, so now we have our formula of simple interest rearranged for time. So let's do our substitution here. So T is going to be equal to I, which for this question is 60. And then we have our principal, P, which is 300. And then it's times our rate. When we put this into the calculator, be mindful. You want to have 60 divided by 300 times 0.08. So what you should get for an answer for time is 2.5 years. So again, we're solving for time. So we want to ensure we include the correct units of years. Okay, so that is our simple interest formula. Now what we're going to move on to is what we refer to as maturity value. So maturity value, which we use the variable S, includes both the interest earned as well as the original principal amount. It's also called the accumulated value and is the total amount to be paid when a loan or an investment comes due. So the formula for maturity value is that S is equal to P times 1 plus R times T. So there is some variables here that we're familiar with already from our simple interest formula. And really the only thing that's new is this variable S, which is our maturity value. We still have P for the original amount invested or borrowed, so our principal. We still have our rate. We're still going to use it in decimal form, and we still have T, which is our time. So if you want to earn a specific amount of money in the future, so what we refer to as our maturity value, one step towards reaching it is to calculate the principal you will need to invest today. So by simply rearranging the above formula for maturity value, we can solve for our principal so that we know how much principal do we need in order to get some maturity value in the future. So we have two formulas for maturity value. They are just rearranged from each other. So let's do this first example here. So for this question, it says a business deposited $10,000 in a simple interest account with a rate of 8% per annum. How much will be in the account after 3 months? Calculate the maturity value. All right, so what we have is this $10,000 value, which is our principal. We've got our rate. We're given time. Now be mindful, it's not time in years, so we'll have to be careful with that. And we're going to calculate S. So let's write down everything that we have. All right, so we have our principal, which is $10,000. We have our rate, which is 8%, which again, we're familiar with this rate as 0.08. And then for our time, we're given that it's 3 months. So again, remember, we want to convert this into years, and we remember that that is equivalent to 3/12 years. Now, this particular fraction can be reduced to a nice decimal. So please, if you would like to use it in decimal form, by all means. And what we're solving for is S, that maturity value. So we're going to use the first formula that we talked about. S is equal to P times 1 plus RT. So let's go ahead and write that formula here. So S is equal to P times 1 plus RT. And from here, we're going to substitute in the known values that we have. So we have that our principal is 10,000. That 1 is just 1, nothing changes. We do have our rate, which is 0.08. And that's going to be times our time value, T, which is 0.25. Close that and notice how we have these sort of nested brackets within those bigger brackets. So it's important that we include those in our calculation, in our calculator, so our calculator knows exactly what to do. All right, so if you've done that correctly, you're going to get a value of $10,200. And again, remember, we want to ensure that we include our dollar sign as well as round our currency or our dollars to 2 decimal places. So if you didn't get this answer, just double check, make sure you have the correct number of brackets when you go ahead and put this into your calculator. And also notice, take a second to realize that of course my maturity value should be more than my original principal, which was $10,000. So always make sure you take a moment to really kind of ensure that your question, or pardon me, your answer is reasonable. It makes sense. All right, so before we stop this video for the next video, which will start with compound interest, let's quickly compare the two. So as we start to talk about compound interest, this is really great at essentially sort of comparing the two. So what is compound interest? Well, compound interest is the concept of adding accumulated interest back into the principal so that any future interest is earned on both the interest as well as the principal each time the money is compounded. So there's a significant difference in the maturity value between compound and simple interest. So this diagram is really great at showing that. So if we start by looking at the linear line of simple interest, we can see that it grows very constant. So there's the blue of simple interest. So notice that we both start here with the same amount of money or principal that has, let's say, invested for the sake of this sort of lesson here. Now, if we take that same amount, but rather than invest it as simple interest, but invest it as compound interest, you can see that the growth initially is similar to simple interest, but then it just really starts to take off. And you can see the difference of compounding versus simple interest. So if we are investing our money, that money is growing much faster if we invest it with compound interest. And again, you can see in this graph, we're looking at sort of years and then that accumulative value or accumulated value, which is sometimes referred to as a maturity value. So on that note, thinking about this particular question, would an investment or loan more interest with simple or compound interest? Well, it's going to be compound. Would this be an advantage or disadvantage, and explain? So if it was an investment, so if we were investing our money, then that would be an advantage because then we're going to be making more money as we sort of leave it in, whatever sort of situation is where it's gaining that compound interest. Now this, though, is a disadvantage if we were borrowing that money, because the longer we sort of borrow the money, the more interest we're going to be paying on it. So ultimately, if we borrow $10,000, let's say, by the time we pay it off, we've probably paid maybe closer to $13,000. So why is that? Well, it's because compound interest generates more interest. So this can be good, or it can be not so great depending on the situation that you're in. So how, when we're looking at questions, as we start to go into compound interest questions, how can you tell the difference if the question is based on simple or compound interest? So we've talked about simple interest already, and in the next video, we're going to start with compound interest. So simple interest by given rate, you'll see it's our percentage. In this example here, it's 6.5% per annum, per year. Whereas compound interest is a percentage, but it gives us a compounding. So this particular example says it's 6.5% per year compounded, in this case, quarterly. So we're going to talk about how that is going to affect our compound interest questions. But if you're looking at a question and you see a percentage with PA per annum or per year, we know it's simple interest. If it speaks about how it's being compounded, then we're talking about a compound interest question. All right, so that's the end of this first lesson for Module 3, Topic 1, Simple and Compound Interest. The next video is going to cover the remaining of the notes.